Now it's time to add better combat logic to the game. The basic plan is to create a new battle class, and we'll put all of the battle logic inside that class. Then in the game session, we'll create a new property called current battle. Its data type will be battle, and whenever a player goes into combat, we'll instantiate a new battle object, put that in the current battle, and that will be bound to the UI so it can report what type of monster it is, what their hit points are, things like that. And we'll probably do this in a functional style like we did with the inventory, where the battle class will be mostly read-only properties, and we'll have a battle service that will instantiate a new battle object anytime something happens. So when your hit points decrease, when the monster's hit point decreases, when you win, or if the monster wins, all those functions will be done through the battle service, which will create a new battle object, and that will set the current battle to the new object. At least that's the current plan. As always with programming, as we start heading in one direction, we might find that we need to change our direction because something doesn't work well, doesn't fit in well, but that's what we'll go with for now. When I started looking at the combat logic, I noticed it's all in the game session class, and I noticed we have a lot of messages that go to the UI. The current structure is that the game session class has a public event called onMessageRaised, and inside our combat functions, we have a lot of raise message calls where we say the text that we want to have displayed in the UI. The raise message function looks to see if anybody's subscribed to the onMessageRaised event. If so, it invokes the function that was tied with that. And in this case, mainWindow.xaml is the class that subscribes to the onMessageRaised event. And whenever a combat function raises a message, it's going to get into this onGameMessageRaised in mainWindow.xaml.cs. That's how we go from the game session class into the main window so we can update the UI. If we pull all the combat logic out into a battle class, and we just have a property in the game session for the current battle, we still need a way for the UI to know about messages. One way we could do that is have the mainWindow.xaml.cs subscribe to an event in the battle class, but then if we start doing other classes that need to notify the UI, like maybe a skill class, as you practice a skill, your skill level raises, or if you have some sort of damage over time or heal over time, basically any sort of game message, we'd have to have events in each new class, and mainWindow.xaml is going to have to subscribe to a lot of events. So instead what we're going to do is introduce a message broker. And the way that works is the message broker class is going to be a singleton, so there's only ever going to be one instance of that message broker class, just one object. Any object in the application that uses the message broker is going to have the exact same instance, so it's kind of a central hub type thing that gets used by everybody. So our battle class is going to have a private message broker variable, _message broker, that's going to call messagebroker.getInstance, and this is how we're going to control every class getting the same object for the message broker. And whenever the battle class wants to report some sort of message, it will call _message broker raise message. That will go to the private variable, call the raise message function on that private variable. Then anybody that's subscribed to the message brokers onMessageRaised is going to get the message invoked. And in this case, mainWindow.xaml.cs is going to also have that message broker object, which is going to get the same object because it's calling the get instance, and it's going to subscribe to the onMessageRaised on the message broker object, and it's going to pass in any text that it gets through that event into its onGameMessageRaised function, the same as it did before. The nice thing about having this independent singleton message broker object is that anything can send a message now. If we create a skill class, if we create a damage over time function somewhere, they can all call the same message broker and be routed through there to anybody who's subscribed. So let's look at the code. The first thing we do is create a new message broker class in the engine project in the services folder. It's not really a traditional service, but it's also kind of a service because everybody's using it and sharing it, so that's where I put it for now. If you notice, the constructor on line 13 is private. So that means this message broker class can only be instantiated by something else inside the message broker class. Nothing outside of it, another class, another object, cannot construct a message broker because it's private. And what we do on line 10 is we have a private static message broker, our s_message broker variable, that's going to call the message broker constructor and instantiate the new object. This is going to be kind of like a backing variable on a property, except it's only ever going to be instantiated once, and because it's static, it's going to be used everywhere. So whenever another class wants the one instance of the message broker object, they'll call this static method getInstance that will return the one single static message broker object that exists in the game, and that's how we're going to make this a singleton. There are some other ways of making singletons, but this is one that I like. It's a fairly lightweight one. And finally on line 17 we have our public event on message raised, and then on lines 24 through 27 we have our raise message function. These are literally just copy pasted from the old game session class. And speaking of the game session class, now we'll go modify it. What we need to do first is add a using engine.services up in the using directives because that's where the message broker class is. And then on line 10, we're going to have a private variable _message broker that's going to call message broker.getInstance. So this is how we'll get the single message broker object as a reference in this, inside the game session class. Then we need to go through the game session class in about 30 different places and change all of the raise message functions to _message broker.raiseMessage. Because we're going to delete the raise message function from game session and we're going to use the one that's in the message broker. There's 30 of them, so you're probably going to be best to just doing a Control H and doing a look for raise message and then replace it with _message broker.raiseMessage. I won't do that now because I've already done that, but this is going to be a lot simpler than trying to find all 30 of them. Once we've done that, we don't need the old message event and message function inside game session, so you can delete the public event for on message raise that used to be here on line 11, and you can go to the bottom of the class and there used to be a raise message function down here on line 350, and you can delete that function. And then finally we'll go into mainwindow.xaml.cs. Again, we'll add a using engine.services so we can actually see the message broker class. On line 16 we'll do a private read-only message broker _message broker, and we'll call the message broker.getInstance. So this _message broker will be our reference to the single instance of message broker that's shared everywhere. And then on line 27, where we used to have _game session.onMessage raised, we'll change that to _message broker.onMessage raised, since that's now where our messages are going to come from. And you may notice I deleted some unnecessary comments. By default, Visual Studio creates some comments for each class, and they don't really add any value, so I just deleted them. After all those changes, we should now have the same functionality, except we're going to go through a different path. The main window, the UI, is going to get an instance of the message broker, and it's going to watch for messages raised through it. Our game session class, instead of having its own event, is going to raise messages through its instance of the message broker class. And our message broker class is ready to be used by any class in the game by going through the getInstance function. Let's start up the game and test it out to make sure it still works. I'll go north, and we see that we get the messages about getting the quest. If I go north again, I see I get the message about there being a snake. I'll use the pointy stick. We get our combat messages, get our victory message and our looting messages. If I go to the recipes tab and craft granola bar, we get our crafting message. If I try to craft another one, I get the message that I don't have the required ingredients. So it looks like our messages are all working. This is going to make it a lot easier for us to go into the game session class and pull all of our combat logic out. Because now I can basically take this attack current monster function and put it into the battle class. Before, that raise message function would have caused a problem because it only existed in game session and not in our new battle class. The same thing with if the player is killed or if the monster is killed and we raise all these messages. Before it was all tied through game session, now it's tied through this independent message broker. And the really cool thing is we don't need to use message broker just for displaying UI messages. We could have more of an event-like message. For instance, if we wanted to, we could control increasing in level through a level change message. In our message broker, instead of having a raise message for string, would have a raise level message or something. And then the player character could subscribe to the message broker and see whenever the level increase event gets called, then it needs to go and increase the level on the player. I don't know if we're going to get that complex, but that's something you need to realize. A message broker is more than just text. It's any sort of message or event that you want to raise that you want other things to subscribe to. It's kind of a cool design pattern. As always, I'll have links below the video if you're watching this on YouTube. The links will be to the support page, to the GitHub repository, to the Discord channel if you want to ask questions there or on the support page, or you can leave questions in the comments below the video. If you have any questions, I'll try to answer them as soon as possible. Otherwise, I'll probably see you in the next lesson when we create the actual battle class.